All right. So thanks for Caroline for the introduction.
Of course.
Hi and good morning, afternoon, evening to wherever you're joining in from the world. I hope everybody's staying safe and doing well in these challenging times. Like Caroline mentioned, I'm Pranav, and I work at Splunk, and I'm a senior software engineer. And as part of this talk, I intend to discuss how Splunk Mission Control, which is a new product in private beta, leverages different Pulsar subscription types. So you guys can see the screen, right?
Yeah, we can see it. We're still on the title slide.
Yeah, let's see the transition works. All right.
Perfect. Yeah,
Okay.
it just went through. Thank you.
Okay, sounds good. So what is Splunk Mission Control? So Splunk Mission Control is a new, it's a cloud native microservices based product in the security space. It's currently in private beta. And the goal of the product is to provide like a unified interface to the multitude of security products that Splunk has. And this product is mainly targeted for the security operations center, or it's commonly called the SOC. Given that Mission Control is a security product, what are some of the core requirements that are driving technology choices for Mission Control? Um, so, oops, there you go. So reliability. Reliability is a pretty big deal. We cannot afford to lose a single security event, and or its details. Imagine how the conversation for a sale or a renewal will go with the customer if we say that, oh, sorry, we dropped your security event, but we promise not to do it again. So reliability is a pretty big deal for the product, for the requirements. Sorry. Second fundamental requirement that we had was this is a multi-tenant SaaS product. So data isolation of tenant data is a pretty big deal. There can absolutely be no chance of exposing one tenant's data to the other. And then finally, this is a microservices-based architecture product. So performance and latency when communicating to downstream services is important. I'll talk about the lifecycle of a security event in the next slide, but we have several things that happen downstream after an event is ingested, like automation, collaboration, investigation. And the propagation of this data to all these downstream services has to happen with minimal latency and reliability. So that's it. So here's what a typical security event lifecycle looks like. Once a security event is ingested, it goes through different stages or phases of a workflow. There could be detection, prediction, where we can use machine learning algorithms to make certain predictions or identify certain patterns. There's automation and orchestration, where automated actions or playbooks can be run to mitigate or take corrective actions for a security event. We can run certain type of recommendation algorithms to automatically recommend certain corrective actions, or what kind of playbooks can be run if we have already seen that kind of a security event before. There's also collaboration. So when you have different analysts working in a security operations or the SOC center, they need the ability to collaborate across the security event. And finally, there's also case management, which would be typically like ticket creation, or who's handling the case, what's the status of the case, what tasks are assigned to different analysts, and finally there's a reporting. Now, not all of these, not necessarily that all the flows in here that are shown in this slide here happen linearly. Upon ingestion of a security event, automation, orchestration, or prediction, recommendation, they could also run non-linearly. But this is just to give an idea of like what are the different stages involved. as part of once a security event has been ingested. So we looked at like the fundamental or the foundational requirements that drive the technology choices for mission control. Let's look at some of the functional messaging use cases we have in mission control. So as part of collaboration and workflows, user notifications are sent to either event owners. So when you have a security event, it can have an owner assigned to it. Notifications need to be sent to the owner when events are assigned to them. There are approval workflows. So when you have corrective actions that need to be taken on certain products, let's say block IP or something, you can have approval workflows. So these approval workflows also need to generate notifications for the approvers. There is data that needs to be populated for dashboard panels. This kind of ties a little bit into the reporting. There are automation and orchestration phases that happen in downstream. So when I say automation and orchestration, these are like the automated playbooks or corrective actions that get triggered automatically when a new security event is ingested. There is other stuff that could happen before the automation services run, like enrichment of the security with additional metadata, like risk, or is this already like a known bad IP, that kind of thing, those kind of things. Well, one of the other, being a security product, one of the other functional use case that we had is around generating audit trail. Each and every action around most of the significant resources that we have in the product need to have an audit trail around who created what resource, who updated what resource, who closed a security event, who changed permissions, those kind of things. The front end of the product is React based, and for all the UI refreshing, we use WebSocket messaging to refresh the UI. The next use case is user triggered resource provisioning. So for certain user triggered actions, like creating of new labels or changing ACL permissions, there are certain set of actual resources that are provisioned in the backend. So that we can populate new panels for, let's say, dashboard, or generate new kind of ACL lists from that. And then the next one is providing playbook, debug log. And finally, the last one is like broadcasting important settings and ACL changes to pods. So in our environment, when we have any ACL changes or setting changes that happen, it happens through a callback, which is received by a single service. And now these settings and ACL changes need to propagate to the multiple services that we have in our environment. To each, actually, let me rephrase that, to each pod that we have in the multiple services in our environment. So these are just a subset of the use cases that we were looking to find a solution to. As we are evolving the product, there are other cases that are emerging. But at the time of making this choice, these were the core functional use cases that we had for messaging. So why did we go with Pulsar? Well, the core Pulsar team, which comprises of the Karthik or Matteo, Sanjeev, they're part of Splunk as part of the Streamly acquisition, and that was probably the biggest decision. No, I'm just kidding. So on a serious note, why did we choose Pulsar? So as I discussed earlier, some of our foundational requirements were we needed like data isolation. So Pulsar supports native multi-tenancy, and that provides us a clean separation of data between the different tenants. This is a pretty big deal for us. For us, any product which wasn't able to meet like some of our foundational requirements was not going to work for us. So native multi-tenancy was a big deal. Secondly, the message level acts instead of using the offset level acts. So the ability to either ACK or NAC a message at the individual message level provided significant ability in terms of reliability. So let's take a sample use case of auditing, um, or let's take a use case of like automation being kicked off when a new security event is ingested. We absolutely have to make sure that some of these events are acknowledged, are accepted, acknowledged, and processed successfully, and not dropped. Otherwise, that's like a pretty big deal for us. Um, the improved performance by adding more consumers without adding partitions. So um, we wanted to improve performance and latency, and when we looked at some of the other products, I'll on one of the next slides I'll go into the other the products that we looked at. But we wanted to have the ability to scale up our consumers in case the burst of messages goes up. The next one is unified messaging. I think this does not this wasn't a requirement, a foundational requirement for us. But in terms of a functional use case, this was a pretty big deal. I think this same message was echoed by some of the earlier presenters as well. And the fact that Pulsar supports both queuing and streaming paradigms, it meant that we did not need to install or deploy and operate two different sorts of technologies for PubSub or for queuing separately. And that's I think, in my perspective, that's a pretty big win. Finally, time to live. So some of our functional use cases needed very little or zero time to live. For example, the WebSocket. If the WebSocket can be sent to the WebSocket service that we have immediately, that's fine. Otherwise, if it gets dropped, that's all right. However, for other use cases like audit, the time to live needed to be high enough so that we made sure that the message always gets processed as opposed to the chance of getting dropped. So continuing on why Pulsar. So the other benefits of Pulsar that we found were the simple producers and clients. This kind of reduces the complexity for developers and increase productivity. So there was no complicated calculations we needed to do about which partition to put into, how many partitions to have, which partition can a consumer can read from, those kind of things. There's also the question of operational overhead. Now, granted that in our case, as a mission control product, we don't manage the Pulsar deployment, but nonetheless, several of our team members are experienced with Kafka and other solutions, and there are immense benefits that are in terms of operational complexity that are simplified by using Pulsar. And lastly, topic creation in Pulsar is lightweight. So the fact that you have three levels of separation that you can leverage. One is tenants, other is namespace, and third is topics. I think that provided us a lot of flexibility. So if we wanted to solve issues like noisy neighbor, or if we see that some of the topics are getting a lot of burst, we can easily create new topics and or separate out at the namespace level, however we see fit. When we were pitched Pulsar by the Streamlio team, it was quite fortunate because that was a time when we were looking for a solution for our messaging needs, and we evaluated Redis and Kafka. Redis was quickly dismissed because of the reliability issues. Like I said, reliability was one of the foundational requirements for us. And even if we use the append-only logging persistence format for Redis, so the only way to attain real good reliability with Redis using append-only flag is if you use the append-only flag with every command issued, and that slows down Redis a lot. So Redis was quickly dismissed based on those considerations. And then we made all these comparisons and evaluations for Kafka. and some of the core requirements that we had were not met in a very elegant way by Kafka. For example, multi-tenancy and increasing the number of consumers, scaling up the number of consumers. And so those are some of the reasons that we decided to go with Pulsar over Kafka. So let's see some of the subscription types that we use in Mission Control. So here's a use case for an exclusive subscription that we use in Mission Control. So there are several times when we have critical settings or ACL changes, and these changes need to be communicated to each pod in each service. We have around about, I would say, 10 to 12 services that comprise our application, and that number is likely to go up. So sometimes some of these settings and ACL changes are significant enough that they need to be communicated to each of the pods. So for this case, we have a consumer running on each pod, which creates an exclusive subscription to the topic, and that way, following the PubSub paradigm or the streaming paradigm, each pod gets the message and handles the settings or the ACL changes accordingly. So use case for a shared subscription. So this is a typical queuing paradigm where we have several use cases like sending out notifications, sending out email, data generated for dashboards or reporting. So in this case, we have a separate consumer service where some of these consumers are deployed, and sorry, there's some kind of, okay, sorry. So we have a separate consumer service where some of these consumers are deployed, and in a typical queuing pattern, these tasks are taken up and just processed accordingly. So on the left side, as you can see, you can have multiple services generating. Either of these services could generate the dashboard data or email notification data or audit records, and the consumers can scale up. I'll talk about some optimization things regarding the consumer service later on. But yeah, so this is a classic queuing paradigm where we don't care about the order, and we just want the messages to be processed successfully. And then, so finally, I wanted to touch upon one of the other shared the subscription types that we use in Mission Control. That's the key shared subscription. So just to give some background before I explain this, how we use the key shared subscription. So I talked about automation earlier as one of the stages of the security event lifecycle. So what is automation? So automation is basically a playbook which comprises of like discrete units of work, which are called actions. So some examples of actions could be block user, create ticket, restart server, or make a S3 bucket public, so things like those. Playbooks are just all these actions put together in a cohesive way. Now, these actions could run sequentially or they can run concurrently. And once a playbook is done running, a final on-finish handler is called as part of the playbook. Now, it's important that this on-finish handler is called only once for marking the playbook as successfully completed. So the challenge we were running into is we had one service which initiates or triggers the running of the playbooks, and we had other service which runs the actions. And if so, actually, let me go in. Let me go into the next slide, and that might be good. So as you can see, the service on the left is the one that triggers the playbook run, and the service on the top is the one that runs the actions. So if we would have used some other subscription type here, so the requirement here was that the same pod that triggers the playbook run should ideally be getting the messages of each of the action runs. and that is necessitated by the need for this on finish handler. So we did not want the possibility that two actions finish concurrently at the same time and reach two different pods, and each of the pods try to call the on finish handler. So to meet this requirement, we ended up using a key shared subscription, where once the playbook triggering service triggers the playbook, it listens for a key. It also creates a shared key shared subscription with the playbook ID. And then once the action service finishes running the actions, it publishes messages using that playbook ID as a key. And that way the messages propagate back to the pod which triggered the playbook. And then once it's seen all the actions complete successfully, it can call the on finish handler. Let's go back. A similar use case for this key shared subscription we had was regarding these action runs that I talked about. Now, there's a possibility that some of these actions could take longer, and there's a possibility that the user might want to cancel an action that is running. Now, in this case, it was important that the command to cancel an action run gets triggered and routed to the actual pod that is running the action. So, oops, I'm going backwards. Yeah. So again, the service on the left is the service that triggers the playbook run or the actions, and once let's say the action is actually being run by the first pod in this picture on the top, and when the action needs to be canceled, that message needs to get routed to just this pod on the left, not to the pod on the right. And so for that, the pods listen or subscribe to the Pulsar topic with using action ID as a key. And if they receive a cancel action message using the key action ID, then they know that action needs to be canceled. So we use that either the playbook ID or the action ID for routing the messages to the correct pod. And oops, I went too far. So those are pretty much the three main subscription types that we are using in our product right now. Like I said, we started out with a fixed set of functional use cases, but as we are evolving, we are seeing that we can leverage the ability of Pulsar in many more places. For instance, when a new tenant is provisioned, there are a bunch of downstream resources that need to get provisioned, and we are looking into leveraging Pulsar for triggering those resources, those resource provisioning actions as well. So far, the Pulsar integration has been really painless. Of course, it helps to have Mateo, Sanjeev, Karthik, and their team, available and help out with any of our questions. But at the same time, there haven't been major issues where we had to, kind of constantly leverage them. We are still tweaking and learning. So for instance, several things we need to optimize. For one of the examples is in our key shared subscription, till one of the messages, till each of the every message is acknowledged, it's going to block receiving the remaining messages. And some of our messages, some of our actions are long running. So we need to monitor those and track those and see how we can better alert our systems around those things. So we don't want the remaining messages to get backlogged. So we're still tweaking those, optimizing and tracking, and measuring how we can better find better solution to that. So one of the things I touched upon in my earlier slide is when we started out, we kind of bundled some of our queuing related consumers in one service. It's a matter of tracking what kind of load are we expecting, and there are some consumers we already identified and we want to unbundle into their own service so that we can leverage Kubernetes auto scaling and kind of scale them up and down as needed. Finally, this using Pulsar also opens up the possibility of a event-based architecture that we are looking into as we evolve the product. And I guess that's pretty much it. What I had. Let me
Awesome. Thank you so much.
Let me see the questions. How did you handle submitting 2 actions but same ID twice due to restart? Yeah, so basically we do have persistence storage where we use Aurora, and if a pod restarts, then it first syncs up with the persistence storage to see what the status of an action is. And that's what is basically used for whether it needs to get sent out again or not. And then what kind of hardware setup did you need for 50K mess? I don't think that's relevant to my talk, but like I said, for us, my team does not handle the deployment and the management or the operational overhead of our Pulsar cluster. So I unfortunately would not have much insight into that.
Okay, great. We have a couple more minutes. If anyone else on the call wants to drop a question in the Q&A. All right, it looks like we are good to wrap up. Thank you again, Pranav, for such a great presentation. And do you want to let people know where they can reach out to you?
Sure. I mean, you can reach me at my first initial and last name at splunk.com.
Okay, perfect.
All right.
All
Thanks,
right.
Caroline. Stay safe, everyone.
Thank you.